Hey, this is David Wells coming to you from Netlify. A couple weeks ago, we asked the Twitterverse if they had any serverless questions. What is this whole serverless thing that everyone's talking about? Aren't there servers somewhere? Etc., etc., etc. So we're going to do a quick video about what exactly serverless means and why should you care as a developer. Without further ado, let's jump into it. So what the heck is serverless? We've heard it. It's a buzzword. Everyone's talking about this thing. Don't I need servers somewhere to do some things? And yeah, that's the reaction we typically see. I see that a lot, actually. People just not liking the name per se. We're going to get into that in more detail. So before, here's your classic room full of servers, and then after, boom, serverless. No more servers. Before, after, any questions. End of video. Just kidding. Let's actually look at what it really means. So this is a typical scenario where you have, clients connecting to your web server. Your application might be running in Rails, Express, PHP, WordPress, whatever it may be. It's running on a server somewhere, right? That's a computer running in a data center or in your own data center, and that's typically how it works. So what happens if we, get on Hacker News and the first post, oh man, that's our awesome app that we want everyone to see. And it's number one. It's gotten 1 billion points so far and a bajillion comments. So let's actually see what this might do to our application. So all that traffic starts flooding into our web server, and this is great. We're popular now. We're making tons of money for our business. We're loving it. All those clients connecting to our server, and then more clients start connecting to our server, and we're like, well, this is good. This is a good problem to have, but will my server be able to handle the load? I don't know. We'll see. And then more clients start connecting, and then it's like, oh boy, the server, the fans are running hot. The machine can only take so much. And then more people connect. The flood of traffic keeps hitting the server, keeps coming in, and lo and behold, we get, our server crashes, and now people are getting that, error response back in their browser. So that's tough. This is a tough scenario. This is a pretty common scenario when you're building something and it actually hits and gets a lot of traffic and you haven't planned for such an occasion. So then your boss comes in and says, Johnson, you're fired. And that's rough because no one wants to be fired, especially Johnson. So Johnson starts to, obviously look for more laptop stickers here and for another job. And also, what actually went wrong? He set up his server, he built his Node app exactly how you should with Express, etc. But it just didn't stand up to the amount of traffic coming in. So he started looking into it, and man, there's a lot of different things that you need to think about when you're running something in production that's going to get a lot of traffic. So load balancing, will my server scale with that traffic coming in? Do I have monitoring set up? Am I monitoring all the server logs for malicious activity, etc., etc.? Is my server patched for security? Heartbleed and all those other nasty things out there in the wild. Am I up to snuff on my security? Are all of my servers, or my single server in this case, is it patched? Or is there a backdoor that someone can come in and hack us and get our customer data? Do I have observability and logging set up, very similar to monitoring? Do I have database backups? Not only do you need replicas for and load balancing for servers, but if you have a single database and it's not sharded out or horizontally scaling, you could run into the same issues where maybe your server is fine, but the bottleneck is actually in your database. And then finally, how much is this costing us right now? It starts to get pretty complex, right? So not, the single server with your Express app running, you run the process and it works on your local machine. It's super simple to do. But as you start to get into these real world scenarios, you start to see that, hey, maybe we need a little more to it. And really, when you start to actually look at what you need for a production load, you start to see an architecture diagram that looks pretty similar to this. So, do we have a CDN set up to cache all of our assets so we're not serving assets from our application server? Do we have cloud storage behind that? Do we have a load balancer set up? So is all traffic not going to one server instance but to multiple ones, so it shares the load? And then caching and setting up your database, etc. So this starts to get rather complex, as you can see. And when I first started looking into this, I had this reaction of, holy crap, I just want to build awesome things on the internet. This seems like a lot. Definitely a rabbit hole to go down if you're not familiar with the DevOps world. Not saying it's not possible. It is absolutely possible to do all this stuff. It's just a lot of overhead that you need to dive into. Let's take a look at how going serverless is going to solve or alleviate some of these problems. So load balancing, monitoring, patching, database replicas, and cost. So these things kind of get abstracted away from us going into the serverless space. The question is, aren't there still servers in the serverless space? And aren't all these things still shouldn't you care about them? The answer is yes. But in the serverless world, going serverless, you are offloading a lot of these concerns to a third-party provider, a third-party cloud provider. So as you can see here, there are a huge number of players in the space. AWS, one of the biggest, Google Cloud, Microsoft Azure, IBM, there are a ton out there. Basically different places where you can actually run your serverless functions, and they will handle a lot of those pieces of complexity for you. So all of those different cloud providers that we just saw, they offer what's called a FaaS, or Functions as a Service. So they're going to run your code on demand when you call it. Let's take a look at some of the characteristics of that right now. So looking at serverless at its core, what does it actually mean? It means that your servers are going to auto scale for you. The code that's running, you no longer need to worry about setting up those load balancers. And if you have enough server instances running, one of those providers will do that for you. It has a pay per execution pricing model, which is awesome because you're only paying for the millisecond execution time of your code. Instead of setting up servers and having them sit idly waiting for traffic to hit them, you actually only pay for when the function code runs. So that's a huge benefit, and that kind of traverses the serverless ecosystem, where it's pay-per execution pricing on a lot of different things, like using databases or using third-party software as a service applications, which brings me to the third point here, leveraging third-party services. So we're already running our app code in one of those third-party services, but what about transactional email services, or if we needed to send text messages from our application? It doesn't make a lot of sense for us to build that in-house at our company unless that's what our company is selling. It makes a lot more sense to use a third-party provider like Twilio to send text messages and do all kinds of telecom stuff, or using SendGrid or MailChimp or any of the other email service providers out there to actually send our applications email. And that lets us focus more on our core business logic, the thing our app is actually doing, the thing that we're selling to make money, instead of setting up these lower level primitives to build our application. Because if you go down that route, it can actually really derail the product development, and you're not shipping useful features for your application. You're working on these lower level pieces that you could have just offloaded to a third-party provider. So definitely a concern to think about there. And then there's this notion of this enables event-driven workflows. So Functions can react to all different types of events, webhooks, infrastructure events, etc. We'll be getting into more of that in a later video, but just using functions and other serverless tools out there, you start to offload some of the actual core business logic of your application to like poll for different things, whether or not they've happened, and instead you trigger events and those will trigger functions and then trigger other things. It's basically a way to kind of eliminate polling in applications and just have a simpler architecture after you've kind of set that stuff up. When you're building out functions, you are basically decomposing a larger monolithic application into smaller functions or microservices, if you will. And that follows the Unix philosophy, where we want to make each program or function do one thing and do one thing very, very well. This lets us build simpler business logic and compose those pieces together to build more robust applications, as we'll see in later videos. So enough with that, everything about what kind of serverless is. What does it actually look like when you're building out these functions and what have you? What we're looking at is an AWS Lambda function. Really at its core, a Lambda function is simple code. It's a simple function with an event, context, and a callback. Inside of the event is information about the request body, the method type. Is it a post? Is it a patch? Is it a delete? And then the data from your AJAX request or from your, whatever's calling this function. Context is information about the function, where is it running? How much memory does it have? How much longer does it have to execute? And then the callback. The callback is actually what ends the function, ends the execution. That's when, hey, when I call this callback, return this response and stop, billing me for this function execution. This example is using Node.js, but there's a variety of runtimes supported depending on what cloud provider you choose. This being Node.js, that means I can use any module from NPM to build anything that I want. So getting into like different use cases of serverless, we're going to dive into much deeper in a later video. But really, you can use it, anything that you can write in Node or whatever runtime you're using, you can do within a serverless function, with the one caveat of if your function takes longer than 5 minutes to execute, that won't work in the serverless landscape right now. So keep that in mind. If you have a very, very long running process, it might not fit into a serverless function. So serverless isn't the silver bullet for everything, so keep that in mind. And I'll leave you with this. Is your wireless router actually wireless? Or is there wire connected to it somewhere? Likewise, is the cloud actually a cloud? Likewise, is serverless truly serverless? See where I'm going with that? So the name's stuck, so we're kind of just, everyone's calling it that, so no way to change that. But you can build some amazing things with it, and we're going to dive into that in so many more videos. So stay tuned. If you enjoyed this video, comment, etc. And if you have any questions on serverless, what you can and can't do with it, different examples, feel free to tweet at me at David Wells. I'd be happy to answer any of your serverless questions. We also have a site set up at whattheheckisserverless.netlify.com. If you want to leave your questions in there and have them answered in a video like this, please drop them in there and we will try to get through as many of them as we can.